So the second page, again, we're looking at this shape and we're deciding, is this linear or nonlinear? Is it a straight line? No, so nonlinear. X-intercept. How many times does it cross the x-axis? Good. Here's our x-axis. It crosses here and here. We don't have those on perfect crosshairs, so we just have to estimate those numbers. What did you say? It's a little bit more than a half, so 1.7. We'll go with that. So right to 1.7, up and down 0. So 1.7, comma 0. And the other ordered pair, probably about 4.7. It's a little bit more than a half. So comma 4.7, comma 0. Great. Y-intercept, how many times does it cross or touch the y-axis? Just once. And that ordered pair is?
1.
0, 1.
0, 1. Left and right, 0, up, 1. Very good. Okay, increasing. Is this graph ever increasing? Yes. Okay, is this graph ever decreasing?
Yes.
Okay, so I'm going to go ahead and draw. So from here, and it changes directions right here. So from here to here, what's happening on my graph? Is decreasing. Now from that same point, it's going to turn around and our graph ends about 6. Now we're going uphill, so that section is increasing. Does that make sense how I'm kind of defining those sections? Okay, so increasing interval, that's our first one. So that's my blue. From 3 all the way to 6. This is the area that it is increasing. So I'll use interval notation, 3, 6. Decreasing is that red area. So from here to here, who thinks they can give me our decreasing interval? Tanner?
1 and 3.
So 1 to 3 would be from here to here. 0 to 3.
0.
So we want to make sure we're looking at here. Our,
Looking at
the number up here. Ah, yes. So make sure, that's a good point. So make sure we're focusing only on the x-axis. So from 0 all the way to 3, it is going downhill or decreasing. Okay, minimum. This is our lowest point on the graph. How many lowest points do you see? 1, and here it is. We'll estimate that, so that's right to 3, down to -1. So 3, comma, -1. Maximum, how many highest points do you see? 2, because they're at the exact same height, right? Those are the 2 highest points. They're the same height. So we'll list both ordered pairs. The first one just happens to be our y-intercept. So that is 0, 1. And our other one, 6, 1. Okay, end behavior. When we go towards the left, y is going towards 1. When we go towards the right, y is going towards 1. Or we can just say, on the left side, it's going up, and on the right side, it's going up. Both sides go up. On the left side, we're going up. It's increasing to 1. So we're talking about what's happening on the end here. Or we can say as x is going towards 0, so we're going towards 0 here at this side. X is 0. Our y is going towards 1. Again, don't stress over end behavior. Okay, over here, x is going towards what number? 6. And our y is going towards 1. So x is going towards 6, y is going towards 1. Or on the left side of our graph, we're at 1. On the right side, we're at 1. On both ends. Okay, the next example, it says Amber was given $8 gift card to Dollar Tree. Each item costs $1. The amount of money left on the card can be represented by the function or equation f of x equals 8 minus x, where x is the items she purchased, excluding taxes. So pretend we're tax-free weekend. Okay, so we want to create a table here. So in our x's, we usually always want to start at 0. And we'll go down 1, 2, 3, 4, 5. F of x, really, that means what? Y values. So how do we find those?
You substitute x into the equation.
Good. Substitute our x number, so 0, into this equation. So 8 minus 0. That's 8. 8 minus x is the equation. So then we have, try to zoom in there for you. We have 8 minus 1. 8 minus 1 is 7. 6, 5, 4, 3. We could keep going. What's this last column? See?
Oh, wait, the x, y order.
Good, the x, y ordered pair. We've seen that before, right? So 0, 8. 1, 7. 2, 6. 3, 5. 4, 4. 5, 3. There's a test question real similar. Now we want to graph this. If I'm graphing, I should always label. So what is on the x-axis?
Items.
Items that we're buying.
Items.
Items bought. Okay.
Is it the price of the Oh, each has one.
Each is $1. So, okay. So now the y-axis here. What do you think that should be? Money that we have, and how is our money represented? It's not cash. It's on a gift card. So it'll be the money on the card. Or you could say value of gift card, right? Okay, so now let's go ahead and graph this. So our first order pair is 0, 8. 0 up to 8. So that makes sense. 0 items purchased. There's $8 on the card. Then 1, 7. 2, 6. Okay. So those are all the points that are in the table. Could we keep going?
Yeah.
Yes. Should we keep going? Yeah. Why not, right? It's a real world situation. We probably didn't just stop with $3 on our card. We kept going. Should I go past this point? No. This is real world. Okay, I wouldn't put arrows on this line because I can't go past. Good, you can't go in debt on a gift card. We can't go past $0 on the card. And we cannot go to the left because we can't buy negative items. Can't do that. It's not a thing. So that's as far as we can go. So that means like if I bought 6 things, there's $2 left on the card. Okay, now let's answer these questions to the right. Identify the initial value for the situation. So initial value is where we started, which is the y. What is our initial value?
8.
And as an ordered pair?
0,
0, 8. Very good. Identify the common difference, aka the rate of change, aka the slope.
-1.
Good, -1. Identify the domain and range. Explain what it means for the situation. So let's do the domain first. This is going to be an interval notation. So left to right. Domain is left to right. So here's our numbers. 0 all the way to 8 with closed brackets. Very good. So that means we're doing items. So that means you can buy anywhere between 0 and 8 items with the card. And it says explain, so that's what we're going to write. You can buy 0 to 8 items with the card. Or I guess this is amber, but you can use you. Okay, and for our range, we're thinking bottom to top. So coming from the bottom side in here, top side stops here. So again, 0 to 8. But that means something different because we're talking about money on the card. So that tells us there can be between $0 to $8 on this card. Anywhere between would work, but can't be less than, can't be more than. So you can have between $0 to $8 on the card. Okay, the next is asking us to find our intercepts, x and y. The x-intercept, where it touches or crosses the x-axis. Say it again. 8, 0. And our y-intercept? 0, 8. Very good. Again, they don't always turn out like perfect numbers like that. Flip it over when you're ready. If you don't have your calculator out, you're going to want it out for this one. It says Kelly and her cousin both signed up for Snapchat. The number of Snapchats received by the cousin on day N is given by the equation S equals 5N. The number of Snapchats received by Kelly on day N is shown on the graph. Over time, whose number of Snapchats increases more rapidly? Give data to support your answer. Okay, so let's go ahead and use, which one's Kelly? Kelly's the graph, so let's go ahead and find the cousins first. So the cousins equation is S equals 5N. So we're going to make this our X and this one our Y. What's X represented as? N. So this is really N. And instead of Y, we have an S. So you may see it as labeled as N and S in the future. Now let's go 0, 1, 2, 3, 4, 5. And let's plug it in. Plug in 0. 5 times 0 is? 0. 5 times 1? 5. 5 times 2? 10. 5 times 3? 5 times 4? 5 times 5. Okay, great. So this is linear. We're adding 5 every time, right? So her Snapchats are increasing at a linear rate, so a straight line. Now let's look at Kelly. We don't know Kelly's equation. However, we could write it. So let's look at this first. We'll just call Kelly's X and Y to start out with. And let's find our ordered pairs 0, 1, 2, 3, 4, 5. looking at our graph, what's her initial value? On day 0, she has 1 Snapchat. So 0, 1. She signed up and she had that team Snapchat notification. That makes sense. Okay. There was a glitch in the cousins. She didn't have that. I don't know. Okay, so on Kelly, now on day 1, we go right to 1 up to 2. So 1 day in, now she has 2 messages. Or photos, whatever it is. So 1, 2. So we're either adding how many to get from 1 to 2? We're either adding 1 or we're timesing by 2. Let's see which one holds true. If I look at this, does this look linear? No, so it's probably not the adding one, right? Okay, so 2 comma, let's not find the perfect crosshair, right there at 4. So the next ordered pair is 2, 4. So it holds true that we're timesing by 2 each time. So that means this is exponential, and we're timesing by 2. So we could find the next ordered pair. It should be 4 times 2, so it should be 8. So 3 all the way up to 8, yeah, it crosses right there. So on our graph, or on our table, we have 3, 8, then 16, then 32. If I wanted to write my equation, good practice for us, y equals, our initial value was 1. We multiplied by 2 every time, and it's to the power of x. You may want that to have that formula if you had trouble finding the pattern. Okay, so ultimately, whose increases more over time? Kelly. And how many days did it take to show that?
4.
4 days in, cousin was still leading. Now 5 days in, Kelly finally surpasses her. Right? So it took 5 days to show that Kelly's messages would increase faster. Okay. So the question is, over time, whose increases more rapidly? I would write Kelly's, Snapchat's, increase faster. It takes 5 days to show this. That's our answer. And we have one last one. You're going to want your calculator out for this one, because these numbers are going to get large. All right, so it says complete the tables using the functions. The functions are right here. We're trying to decide which function increases more rapidly as x increases. So over time, whose increases faster? Why did I write the x? Because I had room for it, and I knew that I had room for on this graph. On your test, you'll have room for it. Because this is my x's and this is my y's. And the example above, I knew ahead of time that I would not have, I would need one more box. That's why I wrote it above it. So you don't necessarily need the x there. What would I write here instead of y? F of x. Good, because that's what it says right there. So now we're going to be plugging in 0 in for this x. So in my calculator, I'm going to enter it just as it says. 5 parentheses 3, close parentheses, to the power of x. So it's that little caret symbol. And I'm not going to put x in, I'm going to put a number in. So the power of, first starting with 0. Enter. And I get 5. Now my calculator allows me to say second enter, and it will type it all back in. Make an arrow to the left and type over it and put 1. So that's 15 now. So we're timesing by what? 3. So let's do another one. Second enter, arrow over to the 1, type in a 2. We get 45. Instead of continuing to type this in our calculator, I could just say 45 times 3. You get 135. Times 3, 405. Okay. Now let's see what happens in the other equation. In the other equation, there's no number outside here, which tells me, what could that number be if we don't see it? 1. So let's begin. So what should I put here instead of y? G of x, because the number or formula says g. So this time we have parentheses 3, close parentheses, to the power of whatever number we plug in plus 5. So 0 plus 5. You can either type in 0 plus 5 after you hit the power button or add that in your head and say 0 plus 5 is 5. 1 plus 5 is 6, and so on. So 243.
I think it's good.
Because it's 6, because when we put the 5, it doesn't include that as.
Okay, so that would be, okay, so you need to do parentheses 3, close parentheses, caret symbol, parentheses again, 0 plus 5. Now press enter. Now does it say 243?
32050.
No, look, guys. I got it.
Do you want to bring it up here? I'll put it under the camera.
I got 1.732
So you have to put the 0 plus 5 in parentheses as well.
That's what we did.
Try to reset your calculator.
Yeah, I'll take a look at your calculator when we're done here. Thanks. Okay, so now when I plug in, and just add it in your head for right now. So parentheses 3, close parentheses, to the power of, what is 1 plus 5? 6. Enter. 729. Now for 2, plug in 2. So 3 to the power of 7. 2,187. 3 to the power of 8. 6,561. 3 to the power of 9. 19,683. It's safe to say we can figure out which one's increasing faster. Which one is it?
G of X.
G of X. Questions?